Good morning, ladies and gentlemen. I'm Myung, and I'm currently working as the Senior Research Fellow at the Korea Atomic Energy Research Institute. And I served as a president of KERI in the years of 2007 to 2010. And as you may know, the KERI, Korea Atomic Energy Research Institute, is the Korean government-sponsored research institute, and whose main role is doing R&Ds for the peaceful use of the nuclear energy. So in this morning, I'm going to make a presentation on the various aspects of nuclear energy as a practical energy source for the future. So for the details of safety and non-proliferation, I assume that Dr. Abdel Khalik and Dr. Kashimo will take more details. So the demands of energy has increased rapidly in the beginning of 20th centuries. However, the supply of energy by the fossil fuel like coal and oil produce the greenhouse gases to cause the global warming. So as you can see in this slide, a future study shows that the sea ice of the Arctic will disappear in 2090, and some future study also show that the temperature of globe will be increased up to 8 degrees C until 2100 years. And the report from Princeton University shows that in order to make the level of carbon emitted in 2050 as the same as that of 2000 to mitigate the climate change, 8 technical alternatives can be considered. So they suggest that one of them is the nuclear electricity and energy efficiency and forest and soil and carbon capture and hydrogen and the nuclear fission. And surely the priority for the technical development will be determined based on each country's energy policy and their technical capabilities. And this slide shows the current status of the world nuclear power. So currently, about 440 nuclear reactor units are under operation in 30 countries to supply 14% of electricity in the world. And IAEA predicts that nuclear power generation capacity will be increased current 370 gigawatt to around 800 gigawatt in the year of 2030. And a major increase of nuclear power will happen in the Asian region and like China and India and also Middle East area. And the other aspect of the fossil fuel is that the available resources are limited to just several selected areas. For example, the 60% of oil resources is concentrated in the Middle East area, and the coal is mainly located in USA, Russia, China, and India. And the natural gas is mainly produced in Russia and the Middle East countries. So due to this regional segregation, the security for energy supply is heavily affected by the geopolitical situation. But in contrast, the uranium resources is relatively uniformly distributed over the world, such as Australia, Canada, Brazil, Russia, USA, Kazakhstan, and South Africa. And moreover, the cost for the electricity generation by nuclear is much cheaper than others. In Korea, the nuclear power generation cost is about 41 per kilowatt hour compared with that of 61 for coal, 121 for natural gas, and 110 for wind, and almost 641 for the solar energies. So in Korea, Korea import about 97% of energies, and the self-sufficiency of energy is less than 3%. However, in case of nuclear, because the ratio of fuel cost to the whole electricity cost is less than 9%. So, and in case of oil, the cost of fuel to the total electricity cost is higher than 90%. So that means the cost of nuclear energy is not sensitive to the price change of uranium resources. Therefore, nuclear energy can be considered as self-reliant energy. So when the nuclear energy is considered as the localized energy source in Korea, then Korean energy self-sufficiency rate can be increased from 3% to up to 20%. And in order to use the uranium as the fuel for pressurized water reactor, the isotopic content of uranium-235 must be increased up to 5%. And the isotopic content of uranium-235 in the natural uranium is just 0.7%. And normally, this enrichment of uranium-235 is mainly performed by the centrifuge method. Then the enriched uranium material will be fabricated to the actual nuclear fuel. So this slide shows some examples of PWR fuels and fuel for the candle reactors, and also some fuel in the North Korea. And when the nuclear fuel is discharged from nuclear power plant after 3 years of burning, in that spent fuel, still 93% of uranium is remained as not burned, and also it contains about 1% of newly produced plutonium. So plutonium plutonium does not exist in nature, but there is artificial isotopic element. So to make a nuclear fuel, so we first mine the uranium resources from mining, and also enrichment of uranium-235, then the fuel fabrication, and also after that, the reprocessing of spent fuel, and the final radioactive waste disposal. And whole this process is called as a nuclear fuel cycle. However, if uranium is enriched higher than 90% of uranium-235, then those enriched uranium material can be used for the manufacturing of nuclear weapon. And also newly produced plutonium can also be used for the nuclear fuel, but also there is a material for the nuclear weapon manufacturing. So therefore, due to this dual aspect, the enrichment process and the reprocessing of spent fuels are very sensitive area in the international non-proliferation regime. And since the nuclear energy was actually demonstrated by making an enriched uranium weapon dropped in Hiroshima, and the plutonium weapon dropped in Nagasaki in the Second World War, so the public concept on the nuclear energy skeptical for the peaceful use of it. And ensuring safety is the basic requirement for the peaceful use of nuclear energy. So nuclear safety can be obtained by controlling the nuclear fission chain reaction, that is the control of the reactivity, which can be accomplished by the control rod and the boron concentration management, and the cooling of nuclear fuel during operation, and also heat removal after reactor shutdown to remove the residual decay heat of fuel, and safe storage of the spent fuel, and the radioactivity containment to prevent the radiation release to the environment. And multiple barriers are prepared in the modern nuclear power plant for prevention of radiation release to the public. So for example, so fuel cladding tubes and 25 centimeter thick reactor pressure vessels and 6 millimeter thick steel lining of containment building and 120 centimeter thick heavy concrete of containment buildings are prepared for the multiple barrier. And this kind of basic principles of redundancy and the multiplicity and the diversity and the defense in depth concept are widely used to enhance the safety of the nuclear power plant. And even though the safety criteria, current safety criteria have been upgraded by the lessons learned from the 3 Mile Island accident in 1979 and the Chernobyl accident in 1986, but still much more improvement will be made and implemented from the lessons from the recent Fukushima accident in March 2011. So main cause of Fukushima accident is the station blackout due to the tsunami, and which make the cooling system inoperable. So many improvements are underway, including the increased coping capability for electricity supply and confirmation of seismic and external flooding design basis, and evaluation of impact of seismically induced fire and flood, and installation of hardened vent, and also installation of hydrogen removal system, and improvement of spent fuel pool cooling, and improvement of emergency plan to consider multi-unit event. So in Korea, about from the middle of the March, for 1 month, we performed comprehensive evaluation of current Korean nuclear power plant, and we find out about 50 improvement items, and that improvement will be implemented in 5 years by using $1 billion. In Korea, currently 21 nuclear reactor units are in operation, which provide about 34% of total electricity generation, and 7 more reactors are under construction as of today. And Korea started the localization of nuclear power technology from early 1980s, and the localization effort has been successfully completed to establish Korean indigenous nuclear technology. And based on the outstanding performance Korean nuclear power plant, Korea has been selected as the supplier of 4 nuclear power reactors to the United Arab Emirates in 2009, and Korea is going to supply a research reactor to Jordan until 2014. But for the sustainable growth of nuclear in the future, we are developing the next generation nuclear system. We are developing the next generation nuclear system, and the main objective of that development is to ensure the safety, to reduce the radio waste volume and the radio toxicity, and improve the economical competitiveness, and enhance the proliferation resistance. And among several candidate technology, Korea is developing the sodium-cooled fast reactor and the dry electrochemical process named pyroprocessing. And by using this combined system, the amount of high-level radioactive waste can be reduced by 20, and the reduction of radiotoxicity can be achieved by 1,000, and the reduction of necessary geological space for the permanent disposal of spent fuel can be reduced by 100, and the increase of uranium resource utilization by 100 can be achieved. And especially the pyroprocessing of spent fuel is a dry process which extracts the plutonium together with other transuranic materials like neptunium and americium. So unlike other wet reprocessing technology like Purex, the plutonium, pure plutonium cannot be separated in pyroprocessing, and which greatly increase the proliferation resistant properties. So in summary, so the desire for the higher quality of life demands the increased use of clean and economical energy. And as 1 kilogram of uranium-235 can produce the energy which is equivalent to 9,000 drums of oil or 3,000 tons of coal without generating greenhouse gases, the nuclear energy has lots of potentials as the practical energy source of the future. Therefore, I believe nuclear energy will keep playing a main role for the supply of nuclear energy in coming 21st centuries, surely with the improvement of nuclear technology to ensure the safety. So thank you for your attention.
Thanks very much.